The Department of Computer Science and Engineering of NIT Calicut is blessed with a committed group of faculty members.
We, the faculty, staff and students in the Department of Computer Science and Engineering strongly believe in good interactive teaching and its benefits to society. Our approach to teaching can be summed up as an attempt to meet the ideal goal set by Einstein. It is the supreme art of the teacher to awaken joy in the creative expression and knowledge.
We have well qualified faculty with masters and doctoral degrees from premier institutions in India like IITs and IAC. Our faculty and research students are doing active research in the major areas of computer science and engineering.
Our focus is on building strong fundamentals of knowledge on which creativity can take wings in the student's mind. We take steps to encourage thinking, which is a stepping stone to creativity, an exercise in concentration and a pleasure by itself. This makes the student well prepared for solving difficult problems and developing those solutions to a communicable form.
The major strength of our department is the highly positive environment that maintains healthy relationships amongst the faculty, staff and students. Our senior faculty inspires and guides us to follow best academic practices, and they motivate the students for pursuing higher studies and the best institutes around the globe.
We, the Department of Computer Science in NIT Calicut, is one of the best places where one can learn theoretical computer science because we have an excellent group of faculty who is specialized in one or other areas of theory such as algorithms, coding theory, computational geometry, verification and distributed computing. Apart from that, our undergraduate curriculum is designed providing thrust to theoretical as equally as systems side of computer science. On the theory front, we have data structures and algorithms with an extensive practical course running in parallel in the third semester and theory of computation in the next semester. We believe that strong basics of theoretical computer science for a student is laid by these two courses. We also have electives such as design and analysis of algorithms, graph theory and combinatorics, information theory, distributed computing, topics in theory of computation, which enable our students to embark into new realms of theory.
Signal processing is a discipline in electrical engineering and in mathematics that deals with analysis and processing of analog and digital signals. Out of all these signals, the field that deals with the type of signals for which the input is an image is known as image processing. By studying this course, a student will be able to explain and apply the fundamental concepts of image processing, design solutions for simple and complex image processing problems using the various spatial domain and transform domain techniques, apply various filtering techniques and segmentation methods for image enhancement and image segmentation, explain and apply the apt noise removal techniques for images depending upon the application, and explain the image reconstruction technique. Image filtering techniques and their practical applications are also included in the course. The techniques of image segmentation and image compression are discussed in the later part of the course. In order to give a proper knowledge about the recent applications of image processing, a student is exposed to problems in various fields such as medical imaging, robot vision, character recognition, remote sensing and so on. The academic performance of a student who credits this course is evaluated through lab assignments, tutorial sessions, quizzes, mini projects, written examinations, etc.
I am Subhashini R, working as Assistant Professor in the Department of Computer Science and Engineering at NIT Calicut. My research interests are in the sub-areas of theoretical computer science, namely data structures, design and analysis of algorithms. Many important algorithmic problems that we want to solve are NP hard. we cannot hope to obtain algorithms which compute the exact solution efficiently for these problems. Over the years, multiple paradigms for coping with NP hardness have been introduced. For instance, approximation algorithms, average case analysis and randomized algorithms were all born out of a desire to solve hard problems by relaxing the problem or strengthening the model.
There are more sophisticated areas in theoretical computer science that may not be of much interest to everyone. Understanding many of the topics in theoretical computer science requires a good grip of mathematical fundamentals. That is one reason why many students find these subjects difficult. And there is also a perception that these subjects are of no use when it comes to the practical world. In fact, that is not the case. Understanding these concepts well helps one to write good or more efficient programs, or even to understand whether a problem can be solved easily with a computer program. If we realize that the problem that we are trying to solve is a hard one, then we can even go for approximate solutions. There are many standard techniques of doing this. Some people say that theory is always ahead of practice by several years, but I don't think that is true in every case. There are areas in which theory is much more advanced, and there are areas where practical solutions are ahead of what theory people have even thought of. Both has its strong points and weak points, but it remains a fact that a good hold of theory always helps you in the most practical kind of jobs as well.
Hi, I am Sumesh, working as Assistant Professor in the Department of Computer Science and Engineering at NIT Calicut. My area of interest are computer vision and computer networks. Currently, I offer a course on computer networking for MTech students. Computer networks deals with the study of interconnecting networks to provide services to end users. Internet has become an unavoidable thing in everyone's life. Also, computer networking is one demanding area in computer science and engineering research, and it is still an area under evolution. So these features make computer networks a subject that cannot be left out in any computer science curricula. The area has a never-ending scope, with the new standards in wireless and mobile networking evolving very fast. There is a great possibility of research in congestion control, security, IPv6, cloud computing and multimedia applications, etc. The CS curriculum in this institute is constantly updated to reflect the ever-evolving nature of the area of computer networks. We teach this course with internet as an example.
I am presently guiding 5 PhD scholars in the area of bioinformatics, especially on problems like drug discovery, using network polypharmacology, new scoring methods for docking using machine learning techniques, and studies on LNC RNA and protein interactions. Some of the expected outcomes from these research works are proposing the effectiveness of non-drugs for new diseases and understanding the role of long non-coding RNAs in gene regulation.
The primary goal of bioinformatics is to increase our understanding of biological processes to facilitate crucial activities such as early diagnosis of diseases and computer-aided drug discovery. The Biocomputing Research Group at our department is actively involved in innovative research in the areas of data and text mining in bioinformatics, computational drug repositioning, and systems biology. Our research group published a good number of research papers in reputed international journals such as BMC Bioinformatics and Elsevier Journal of Computers in Biology and Medicine.
Hi, this is Srinivasa T.M., working as an assistant professor in the Department of Computer Science and Engineering since 2007. I am basically interested in doing research on DNA computing. It is a non-traditional silicon computing, so which uses molecular biology, biochemistry, and as well as the DNA for computations. So basically it is a very high-speed computations with FPGAs, which will provide solutions to the large complex size problems in order to improve and enhance the speed and performance of the solving of a complex problem. I am very happy to welcome all the people who are interested in unconventional computing for the future. That is what DNA computing.
As an academician, I was mainly interested in teaching the courses like image processing, pattern recognition, microprocessors, operating systems, computer programming, etc. My major research areas include image processing and machine learning. I have guided 17 PhD, of which 9 have acquired the doctorate degree so far. I have guided more than 70 MTech theses and many MCA and BTech projects. I was able to publish about 100 papers in international journals and about 75 papers in international conferences and national conferences. I have successfully completed 6 sponsored projects, set up many labs including image processing lab. My research students occupy high positions in academia and industries. After retiring from the department, currently I am working as professor of Indian Institute of Information Technology, Kottayam, which is being mentored by NIT Calicut. I am able to still associate with the department due to this collaboration and also through my research students who are working under my supervision and guidance. My colleagues of CSED department and myself were successful in building a strong department, faculty members and staff with high commitments to the students and society and full of enthusiasm and self-esteem. We are committed to building strong foundations of subject and to work together for the betterment of the department and institute. I am sure and strongly believe that my colleagues will be able to carry forward the esteem of the department in future too.
The CSE department has a total student strength of approximately 850, with around 260 students getting admitted every year for various programs including UG, PG and PhD.
Our department has many faculty members who are well versed in various areas in theoretical computer science, and there are a few undergraduate students from every batch who develop a taste for theory and do research in related topics.
In the placement front, over the years, our students top the list in terms of percentage placement, highest salary and average salary offered by companies.
Our students are currently doing research in theory at top institutes like Tata Institute of Fundamental Research, Institute of Mathematical Sciences, Chennai Mathematical Institute, Indian Statistical Institute, IITs and universities abroad.
The excellent placement records, alumni presence as researchers and academics at the best institutes of international repute, and diverse and unparalleled honors like the Oscar and innovation awards at various industries like the IBM and Google bear testimony to our students' passion for creativity.